We will start with the tests now, which are the hardware tests, namely the binary input and output, plus. Okay, after we have set up our system, we will press and start telling it. It will start asking you about your ID, which was 6 zeros here, 6 twos. Your ID was 6 zeros here, 6 twos. Of course, the password, even in SIPROTEC 4, you were able to change it, but let's say by default in every relay, it remains like that. So let's not change it and leave it as it is. 6 twos. Of course, as soon as you send to the relay, what will happen next is a restart for my protection relay. Now we will need to test, and of course, as we know, by injecting 125 into the input itself. I will need to make a binary or its measurement less than, and I also need to check the pulse by injecting current values and voltage values and start to see against what, and see how much my error is. Okay, so now it's sent on the setting that I put, or whatever it is. Now it's on my relay, and my relay is working. The idea now, quite simply, is that here, everything I'm working on, every time you send or receive, no, I want to stay all the time with. So what happens? What happens here is that in the menu, under the word project, there is something called online access. When you go under online access and start communicating with the relay, whether you sent to it, pulled from it, or even just connected the USB to the front port of the relay, it will start showing you SIPROTEC face devices connected via USB. You open it and you tell it to update accessible device. After you tell it to update accessible devices, it will immediately show you, of course I clicked on it before, it will immediately show you which device is assigned or communicated with you and will give you the communication icon. So you will open your relay, HC, and inside your relay you will find a set of menus. You want to know what these are about, so quite simply, the first thing you have is something called Open Browser. When you open this Open Browser, it will open a web page for you like this. Say, okay. In the Open Browser, as you can see here, you can access the device, change the date and time, go into the settings and view the input, output, LED and measurement and so on. Even the record can be viewed. For example, if I click on settings, I can see a set of settings that I can access, like our function group. Inside the function group, I have, for example, the overcurrent, which starts to show you definite time 1, definite time 2, and the inverse. You can change your settings. What can you change in your settings? From here, so all of this is as if you are working on what? From, exactly here, right? Very nice. Okay, you can access, if you enter here, you will start to see here what has been set up. For example, for you, it's number from the beginning, and this is its own. If this is programmed with something, it will come to you here, or what is it programmed with? And if this is programmed with something, it will show you here or what it is programmed with. And you can see whether it is directed towards the input, intermediate or not. Certainly this applies to the input, and for the output, the same applies. The output numbers, their names, whether they are input or intermediate, and the same applies to the ID. You can access the recorder and retrieve the existing fault from your side. You have the relay, and therefore this page is very useful for the maintenance team if you want to access the relay just online without pulling any settings or anything. Just to see the input, see the output, check their status, see your measurements, what your measurements are like as operational values, as symmetrical components, as energy, and take readings, whatever they may be. You can retrieve your fault, everything that might be available to you. Very nice. Okay, the other thing is that you can go and open the log that we saw in our system, etc. You can open which one? The one with the recorded faults. You have it, and you have it. We will open it now to test. So here I have something called this swash, the one you will access. You have it, and you have it. We will open it now to test the system. So here I have something called this is the one I access. When I entered here in the wiring section, I told him I want to activate the commissioning mode. He said, okay, let's focus on something. He mentioned that the monitoring of binary input, output, and LD can be performed. I said, great. He told me to activate the commissioning mode in order to perform the wiring test. I said, okay, and activated the commissioning mode. He asked me for the password. So I entered my 6.2 password and the relay went into test mode. I noticed the error light turned on, and now you can operate the relay normally in test mode to test the input, output, and LED. If you go to the simplest one among them, the LED, you'll find all the LEDs with their names displayed here. You can press on or off and start monitoring the LED on the relay screen to see it light up and turn off. Well, if you perform a binary output, these are my binary outputs. For example, if you have a specific binary output, let's assume binary output 1.04, and if you want to perform a binary output, or 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 perform a binary output, whether you want to close it or what, or you want to open it. Nice, very good. So you can press on any of the binary outputs and start placing the terminals of this binary output on the multimeter and check the continuity. What is your continuity? Okay? And regarding the binary input through your injection, meaning if I come here and give this binary input an on, if we notice the binary input, which is 2.1, here I remove the binary input. I set the binary input to on, so this is its current value. What is its status when it's on? Okay, so you've seen the banner input. Now regarding the banner output, if you click here, for example, you might find that the banner output isn't working. So why isn't it working? We'll go back to our settings that we mentioned earlier, open the settings, go to device settings, and then say, I want to operate the banner output under the test. So you need to check it here. And then resend your settings to read it, telling it to load the configuration to the device. It says field to get write access to device, release existing write access by online editor, meaning you might currently be connected to it here. So I'll go back to the page I was on and tell it to exit. Yes, exit and return to mine. Editor, meaning you might currently be connected to it here. So I'll go back here again to the page I was on and tell it to kill the process, exit the process, and return again to my process mode. All right, and then I go back again and start to, what I tell it, of course, as soon as you take it out, it will return again. And when you bring it back in, or if you take it out, I mean, it must do something to return properly. I have changed now. I made Fatiji step on him and tell him, under test, so you come and press it and tell it. Okay, after that, it's just done. I simply go back here right now and then open my relay system once more. And I will come and tell it that it has done it, and I will come to, for example, what I have connected, and I will come or give it to work. It works with me, as you can see. So the whole idea is that you had to tell it or tell it on that I allow the banner or button to work. Does it show? Like that. That's nice. Okay, I'll go back again very normally. I have now finished testing the input, output, and LD. I should test all the inputs, all the outputs, and all the LDs. What's left for me is the measurement. So in measurement, quite simply, we will use test devices like the Frija. We will set the frequency to 60 Hertz. We will go to the general page instead of sequence, and we will choose manual, very normally. We will verify the full voltage and set the phase from 120.3 to 69.28. 120 divided by 3, which is 69.38. I start here by telling it to keep it standard, and thus the three phases are the same, with the currents being 1 ampere on all three phases. Let's say, for example, the current has an angle of negative 30, which is 330 degrees phase shift. So, quite simply, you will come here again to access your relay, but this time we will go to the word measurement. Under measurement, there is something called the power system, which you can see some things. All right, you have the feeder, the gap of the feeder, or the group of that feeder. What can you do? You can put, or you can read, the voltage, and so on. And of course, this feeder is the group that I originally created, which I named. I did the naming normally. That's why it appeared in front of us with the word. You can read all your values. And here you have anything you can read. All right, so I bring up the page in front of me like this, and here are the values I can open mine. I set the voltage ratio to 1000 to 1, voltage ratio to 13800 on 120 volts, resulting in 69.28, 69.28, 69.28. The angle here is 0. This won't change for you. This is your reference angle, so don't change it. 240, 120. When it comes to the aircraft, you set the angle to 330, that's correct. And based on your injection device, it's 210, then 90. So you set it here to 210, then 90. All right, and choose yours at 60 hertz. Of course, as you can see here, this is the voltage of the current, and of course, the relay will take it as it is. That's why I drew it for you starting from 0. And you won't find the current here. Your current will start to be delayed because you set it to negative 30 degrees, meaning it lags by 30 degrees. Is that clear? It lags by 330, meaning it lags by 30 what? 30 degrees. Is that nice? And here you have a diagram for the voltage and the current. Indeed, it lags by 300 because it lags by an angle of how much? By an angle of 30 degrees. Clear. Very nice. Right. Great. Okay, let's go back to our injection. Of course, through the Excel sheet, it calculates all the values of the currents, the voltages, everything you need is available. So you will start injecting the response and the peak voltages, everything you need is available. What is available to you? And you start to see all your readings. Of course, I expect that the angle here, the current lags by 30 degrees, so you have it lagging by 30 degrees, meaning the voltage angle is 0 minus 30 plus 30, which falls in the first quadrant. So I expect that both the power value and the reactive power value will be positive. Alright, so cosine 30 is 3 at 2, which is 0.866, and sine 30 is 0.5. So you'll find that the power value is greater than the reactive power value. You'll find all the voltage and current values, everything you need if you have symmetric components. If you change the current values or voltage values, you can monitor your values. Of course, here, the fundamental component with your angles allows you to see with your angles. You can see the voltage values and the current values you have. Clear? So, I have finished the input, output, and load, and also completed the conditional part.